Hello, my name is Devansh Agarwal, and I am a junior majoring in computer science at the University of Texas at Dallas. Today, I will be discussing the difference between supervised and unsupervised learning and when to use which. So let's get into it. The purpose of this presentation is to determine the difference between supervised and unsupervised learning and situations in which one should use either. And the background is machine learning. And what is machine learning, you may ask? Well, machine learning is a branch of artificial intelligence that enables systems to learn and make decisions or predictions based on data without being explicitly programmed. It involves designing and using algorithms that can identify patterns in the data and improve their performance over time with more data or experience. This presentation explores the viability of using machine learning for certain applications. In addition, this report will offer recommendations for when to use which. So first, I will discuss what supervised learning even is. Supervised learning is a machine learning approach where we train a model to discover patterns in labeled data. The labeled data includes both the input and the corresponding output, enabling the model to learn the relationship between them. After training, we evaluate the model's effectiveness using testing data that it hasn't seen before. Supervised learning is commonly divided into two main types, regression and classification. Regression is used to predict continuous values, such as house prices or temperature. Examples of regression techniques include linear regression, which models a straight line relationship, polynomial regression, which captures more complex patterns with curves, and random forest regression, which uses an ensemble of decision trees to improve accuracy. By contrast, classification is used for predicting discrete categories, such as determining whether an email is spam or not. Supervised learning is a foundation of many real-world applications and is essential for understanding data-driven decision-making. Now let's discuss unsupervised learning. Unsupervised learning is a type of machine learning where the model works with unlabeled data. Unlike supervised learning, there are no predefined outputs, so the model independently identifies patterns and structures in the data. This approach is ideal for exploring datasets and uncovering hidden relationships or groupings. Unsupervised learning can be divided into two main different types, clustering and association. Clustering groups data points based on the similarities with common methods like k-means, which divides data into clusters, and hierarchical clustering, which creates a tree-like structure of nested clusters. And finally, there's another one, which is called principal component analysis, or PCA, which reduces the dimensionality of data while retaining the key information, making it easier to visualize or process. On the other hand, we have association, which is used to discover rules that describe relationships between items, such as in market-based analysis, where it helps identify products that are frequently bought together. Unsupervised learning is a powerful tool for gaining insights when we don't have labeled data to guide the process. Now I will discuss the models that I created. I did this to demonstrate the difference between supervised and unsupervised learning, and I used two data sets, the Austin weather data and breast cancer data. For the Austin weather data, I use supervised learning to predict the weather using the average temperatures. And for the unsupervised learning model for Austin weather, I used used techniques to identify patterns within the data, such as the seasons. And for the breast cancer data set, I chose unsupervised learning to uncover key characteristics and groupings within the data, such as patterns and tumor features. However, there's a reason why I did not create um, a supervised learning model for this data set. And that is because it has a large number of features and lacks the labeled structure needed for supervised methods. This reflects a real-world challenge where datasets are complex and may not be well suited to certain learning approaches. And now I will discuss the criteria that I measured this against. The first criteria was goal of learning, which discusses the aim. Is it to predict specific outcomes? Is it to uncover hidden patterns? And the next one was nature of data. Does the data set have labels or is it unlabeled? Supervised learning requires labeled data, whereas unsupervised learning works with unlabeled data to find the structure. Finally, we have learning efficiency with limited data. That relates to how well the model performs with data that doesn't have that many data points. Next, I will discuss the supervised learning model. My supervised learning model focused on predicting the weather and addressing the specific goal of forecasting future conditions based on past data. This was possible because the dataset was labeled, providing clear input-output pairs for the training. And with the limited data, however, the model faces some issues. Because it relies on past data, it is not able to accurately predict future data, or rather test data, based on a smaller sample size. So this model demonstrates the strengths of supervised learning and predictive scenarios. However, it also highlights the dependence on data availability and quality. As we can see here, my model was able to predict with great accuracy the values of the actual average temperatures for that day with a very low mean squared error. For my unsupervised model, I focused on two key goals. My first one was the identifying the seasonal patterns within the weather data. And for the breast cancer data, I explored correlations within the data points. And this worked because the data was unlabeled, as in there was no predefined outputs. And one of the advantages of this is that it can work with limited data because it simply needs to group it. It needs to find patterns. It doesn't need more data. Of course, it helps, but it doesn't need it. And this makes it very useful for data sets where labeling is impractical or unavailable. And so this works best when the objective is to explore and discover insights within unlabeled data sets rather than relying on predefined outcomes. This is the output of the unsupervised learning model for the weather data, and it can be seen that it was able to accurately depict and group the four seasons throughout the year. This graph shows the output of the unsupervised learning model on the breast cancer data, and it can be seen that there are two main groups that it can form, with two main principal components that attribute to this grouping. This shows the most relevant features within the principal components, and it can be seen that for principal component 1, the main feature was concavity, and for the second principal component, the main feature was fractal dimension. And my recommendation is that for tasks where the dataset is labeled and the objective is to make predictions, unsupervised learning is the ideal approach. On the other hand, for unlabeled datasets where the focus is on discovering patterns or relationships, unsupervised learning is the better choice. By aligning the learning approach with the data and the goal, we can maximize the effectiveness and efficiency of our models. This recommendation highlights the importance of understanding both the dataset and the problem when selecting a machine learning approach. Here are the references that I used, and here's my contact information. Thank you so much for listening. Have a good day.